Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, welcome to another session of EPO 640. Okay, electric drive. So for today, we will be discussing. Okay, so for today we will be discussing on the topic of electric drive concept, method, and design tools, part 2. Okay, so in the past lecture we have discussed. Okay, um, that for electric drive. Okay, so there are two things that we look into, two items that we measure. That is the torque and also the speed. Okay, so in other terms, you also measure the horsepower. So horsepower, okay, so horsepower can be translated into watt. Okay, so in this case, horsepower is how fast you hit the wall, and torque is how far you take the wall with you. Okay. So let's look back at the components of the electric drive. So you have your motors. Okay, so the motors can be a DC motor. Okay, it can be a permanent magnet. It can be wound field. Okay. So also you have AC motor types. It can be induction motor. It can be synchronous. It can be brushless DC. Okay, and we look into the what suitable motor. Okay, for which application. Okay, the cost of the motor, and also the environment where we put our motor. And also components for power source. Okay, so power source for your motors, it can be in DC. Okay, it can be regulated. Okay, DC fuel cell. Okay, regulated. It can be also unregulated. Okay, PV. And it can be also a AC source. Yeah, it can be a single or three-phase source. Okay, so wind generator, it can be unregulated. And then you have to power up to connect the motor with the power source. We use a power processor. Okay, so it provides a regulated power supply to the motor. Okay, and it can be a combination of power electronics converter. Okay, so using power electronic converters, it's more efficient, more flexible, more smaller, compact. So you can convert from AC to DC. Okay, or DC to DC, okay, DC to AC, or also AC to AC. So as previously we have discussed, okay, so you have your electric motor, okay, serves the mechanical load, okay, and the power supply was supplied by the converter, will supply the energy to the electric motor, okay, and with the help of the sensors that is attached at the load, the motor, and the power electronic converters, and also at the power supply, power source. So all this information will be connected to the controller. Okay, and the controller will supply the switching signal to the power electronic converter. Okay, based on the user requirement. So DC drive and AC drive, you have advantages and disadvantages. Okay, so basically for DC drive, you have advantage on the control unit, which is a simpler control unit, but then disadvantage in the motor. Okay, and for AC drive, you have advantage in the motor, but you need more complicated control unit. So here you have the comparison between DC drives and AC drive. Okay. Okay, the advantages and disadvantages. Okay, so you can look into your notes for this. So DC drive basically has been used as prime movers. Okay, so it has been used since the early days of industrial ages. So it has been dominated the speed application. Okay, so before the introduction of power electronics, and of course, AC drive will replace DC in the near future. And but then more modern factories, so they are opting to use AC drive, and it will replace DC drive at a slow rate. So again, DC motor, you have the advantages of a simple control, okay, but limitations such as you need maintenance, the cost is expensive, it's very big, very heavy, and also because of brushes, so they introduce sparking, okay, in your motor. So next we look into the general torque equation. Okay, so Newton law. Okay, I forgot first, second, or third law. So you have your force equals to ma. Okay, so force, mass, and velocity. Okay, so that's for linear motion. So for rotational motion, it's quite the same, but they use the term torque. Torque T, okay, equals to the momentum of, okay, inertia, okay, and times d over dt, okay, differentiate of the speed, okay, angular velocity over time. So here you have the mechanics. Okay, so from Newton's law, you have F, okay, F mass, okay, in the positive direction, and then you have friction in the, okay, opposite direction. So the first order differential equation is for speed, and the second order differential equation is for displacement. Okay, same thing with rotational motion. Okay, so you have T producer, torque electric, okay, in the positive direction. Okay, in this case it's clockwise. Okay, and TL is anti-clockwise. Okay, the opposite direction. Okay, so the first order differential equation is for angular frequency. Okay, and second order is for the position, for the angle. So you have your torque dynamic, JD differential of your speed, okay, omega m. Okay, it's the torque dynamic. Okay, it's present during, okay, transient. Okay, so again, d over dt, okay, the differential between omega m, speed is the acceleration. So then you have a condition where two separate okay, this happen. So you have the red and the blue. Okay, so you can see that for the red condition, the torque value is higher, okay, compared to the torque value of the blue. Okay, but blue, the torque applied is longer than the red. So you can see that more torque, okay, the higher the value of torque applied, okay, the faster the acceleration is. So next we see the combination of the rotational and the translation motion. So you can see the relationship between the linear, Okay, linear force with torque, okay, rotational force. So you can say that T equals to radian Fe, Te equals to Rfe. Okay, so R power to 2 times mass is equivalent to the moment inertia of the linearly moving mass. Okay, so at constant speed, okay, Te is equals to TL. Okay, so same thing at the same condition. So you have for different TE, you have the TL. Okay, so during the point here, so you can see that TE equals to TL. So this graph is a bit off a little bit, so it should be here. Okay. And next we look into the torque equation, torque speed quadrant operation. Okay, so for our last lecture, we swap the y-axis. Okay, so in this case, as I mentioned before, you have different textbook with different explanation on the four quadrant speed, torque speed quadrant operation. So in this case, y-axis is speed omega, and x-axis is torque. Okay. So you have 1, 2, 3, 4 quadrant. Okay. So usually what we look into is whether the position of the speed and the torque. Okay. So in this case, in quadrant 1, okay, both the speed and the torque is positive. Okay, and okay, also the power is positive. So in region 2, so you have your speed is positive, but your torque is negative. Okay, so power is negative. And in region 3, both are negative, so your power is positive. Okay, and in quadrant 4, okay, you have your torque and your speed is okay, torque is positive, speed is negative, so your power is negative. Okay, so you can see that if your power is positive, it's on a motoring, okay, motoring condition. Okay, whereas if power is negative, it means that it's supplying motor. The motor is what you call it? The motor is supplying to the power source, to the battery, for example. So again, for quadrant operation, okay. So the direction, okay. So usually we choose whether the direction, the positive direction, okay. So is the speed is arbitrarily chosen. So either it's clockwise or anti-clockwise. So in this case, the direction of positive torque will produce the positive forward speed. Okay. In this case, it's anti-clockwise is positive. Okay. So hence you have your torque. Okay. Your torque also is in the anti-clockwise. Okay. Positive. Okay. For motoring. Okay. Again, speed is positive, but your torque is negative. Okay. Forward braking. Okay. Quadrant 3. Both of them are in reverse. Okay. So reverse motoring. And for quadrant 4, you have negative speed, positive torque. So it's reverse braking. Okay. So yeah, what is important? So for different textbook, they have different ways of explaining this. So what is important is you have to look into whether the direction of the speed and the torque. Okay. So in a lift system operation, okay. So for example, you have your cage, okay, where your passenger, okay, passenger cage. And at the other end of the fulcrum, you have your counterweight, okay, and you have your motor, okay. So motor, if it's okay, if you have weight in your cage, so it will introduce negative torque, okay, during the when your cage is okay, it's going up, okay. So again, this will be discussed in tutorial session, okay, and we will discuss further this on our tutorial session that we will do during tutorial during our discussion, okay. So again, like we have discussed before, the ratings of your converters and your motors, okay. So you have your maximum speed limit, okay, and this will be the base speed, okay, base speed, okay, depending of the power of your motor, okay. So this will be the power limit, okay, and also you have your transient torque limit, okay. So transient is where you have instantaneous, okay, inrush current, okay, during transient, transient during initial turn on, okay. Then we will look into the speed profile, okay. So speed profile, and this will be done in also in your tutorial, okay. We will discuss this. Hopefully you can do this by yourself, and we will discuss the answer during tutorial, okay. Okay, so our next discussion will be on braking. So three types of braking: we have regenerative braking, dynamic, and also plugging or reverse voltage braking, okay. So thank you, and thank you for listening to this session.